So here is another problem on application of Cauchy's integral formula. So the first step is to find the poles of the integrand. So let's specify what we have in the question. So solution here, the integrand is f of z equals to e raised power z divided by z minus 1, z minus 4. So the first step is to find the poles by simply taking the denominator of the integrand and equating it to 0. So poles, you take the denominator, you equate to 0, i.e. z minus 1, z minus 4 equals to 0, which implies z equals to 1 and z equals to 4 are simple poles because these linear factors, each one of them is raised to power 1. Simple poles. So that's step 1. So without loss of generality, we can call this one Z1 and call this one Z2. Now, immediately you get the poles, then sketch the circle or the curve given to know whether all your poles are within the region or outside the region. So this means, by definition, circle, center, z equals to 0, or simply the origin, radius, 2 units. That's what it means. So we have this. So where this -2, this +2, this is 2i, this is minus 2i. The thing is that these are 2 units from this origin. So this is the origin. So we know this will be 1, this will be -1, this will be 3, this will be 4. So clearly you can see that of these 2 poles, only Z1 is within the circle, but Z2 is outside. So what is outside, we don't care about it because the integral around that given pole or any small circle drawn around that given pole will be 0. So this is what we concentrate on, this one that is within the specified circle. So of these 2 poles, only Z1, which is given by 1, lies within the circle C given by this equation. So we use this formula, integral along C of f of z, z minus a dz, to evaluate the integral about this point z equals to 1. Now, so integral along C, we had e raised power z, z minus 1, z minus 4 dz is the same as, because now z equals to 1 was obtained by equating this linear factor to 0, then we have to eliminate this one in the denominator so that our integral will have this general structure. So we use this one. Actually, the solution for this is 2 pi I times FA. This Cauchy integral formula. So we do that one by dividing both the numerator and denominator by z minus 4, z minus 4, so that this and this cancels out. So we'll have integral along C, e raised power z over z minus 4 divided by z minus 1 dz. Actually, this is the same as the original integral when you simplify it. So, which implies that f of z will be e raised power z over z minus 4. A is 1. So this implies that f of A equals to f of 1, which will be e raised power 1 over 1 minus 4, which will give us e over minus 3. So therefore, the integral along C of e raised power z over z minus 1, z minus 4 dz will be 2 pi I times f of A, which is 2 pi I times f of 1, which is the same as 2 pi I times negative e over 3. So which will give me minus 2 pi I over 3 times e. So that is the solution for that given problem. So if the circle was big enough to accommodate even this point z2, which is equals to 4, then you'll have to do the computation for this other pole and then add the two solutions. But as the question was specified, then only the value that matters is this z equals to 1. Thank you.